In this video, I will quickly show you how to use Weka for data mining purposes. Weka can run in the command line, Explorer mode, Knowledge Flow, and Experimental mode. Let's first look at Weka Explorer. With Weka Explorer, you can pre-process data. For example, you can load, analyze, and filter data. Filtering data here means data pre-processing with discretization, normalization, resampling, attribute selection, combination, etc. You can visualize data by compare pairs of attributes, plot matrices, etc. You can do classification, clustering, association rules. You can select features. Now let's look at some examples. In this example, you use the insurance dataset. So first, you click the Open File button and look for the insurance dataset and open it. On the left, you see the list of attributes, and when you move through the list attribute, on the right you see the visualization of the histogram of the corresponding attribute, as well as the statistics of the attribute. You can also use Weka to connect to a database such as MySQL or Oracle. You can also open a link or URL and get data from it. And if you want to edit the data, click the edit button and then save the data to another file. If you want to do some pre-processing on the data, then click the button choose in the filter group. So there are pretty much different types of filters that you can use, as I mentioned in the previous video. For example, discretize, nominal to binary, normalize, numeric to binary, numeric to nominal, remove. Remove here means if you want to remove an attribute to exclude it from the dataset. Standardize, string to nominal, and you can try those. And also there is principal components. And then if you want to do classification, then click and switch to the classify tab, and then you can click the choose button to select different types of classification algorithms in a number of I think there are 8 groups of algorithms. If you want to try the the decision tree algorithm, then look for the trees group and select J48. J48 is the C4.5 algorithm, and then from there you can select the test option. You can use the training set, meaning you use the same set that you used previously for training to test data. You can also supply the test set separately, or you can do cross validation by dividing the dataset into 10 folds, and then look through the folds. Use a number of folds for training and the rest for testing. And you can also do percentage split with let's say 66% for training and the rest for testing. And just click start. It runs quickly and then give you the result. So in the result, it shows you the list of attributes as well as the tree. So you can see, look at the trees, and for example, you can see which attribute was selected for splitting first and second, etc. And what is the number of correctly classified instances, and what is the percentage, which is actually the accuracy, and the number of incorrectly classified instances, and several other statistics. What is the true positive rate, false positive rate, precision, recall, F measure, ROC area, and the confusion metric. And look at the confusion metric, you can see the result is not very good, okay, but not very good. 666 instances from class A were correctly classified as class A, and also 187 instances from class B is correctly classified as class B, but there's also a large number of 86 instances from class B were incorrectly classified as A, and 76 instances from class A were incorrectly classified as B. And on the tree, to understand the numbers in each leaf, here you see two numbers. The first number is actually the number of instances reaching the leaf, and the second number is the number of instances that are misclassified. Next, I will use another algorithm, which is a root-weight classification algorithm with the same insurance dataset. And here you choose JRUF. JRUF is the one that implements the Reaper algorithm. And then also set the test options and click Start to run the algorithm. So here I also select percentage split 66% for training and click Start, and then returns you the result with also the list of attributes and then the rules. So basically the rules can be derived from the tree, and 1, 2, 3, 4 rules, five rules. Now here it shows you the accuracy with also the number of correctly classified instances and incorrectly classified instances, and the detailed accuracy by class with true positive rate, false positive rate, precision, recall, F measure, ROC area, and also the confusion metrics. Here you have 60 instances from class A misclassified as, from class B misclassified as A, and 15 instances from class A but misclassified as B. If you select output prediction, then it also gives you the output. And run again, and here you see the predictions on the test dataset. So for example, for the instance 1, the actual label is no, and it is predicted as no as well, and the probability distribution is this. So like the probability for being no is 0.9, for being Yes, is roughly 0.1, so it is selected as no. And this actually the options can be for other algorithms as well. And in here you can also see other options that you want to see, for example output entropy evaluation measures. Next I will try the nearest k-nearest neighbor algorithm with the same insurance data set. And for selecting k-nearest neighbor, I look for the group lazy and select IBK. And then click the text box area, and here you see options for the algorithm. And here, for example, you can change the number of the neighbors to, for example, 3, and you can change, or you can just leave the other options the same. Distance weighting can be no distance weighting, or maybe weighting by 1 divided by distance. So the farther an distance is, the less it contributes. And then click start. So k-nearest neighbor performs with worse, with lower accuracy. And this is a confusion matrix with larger number of misclassification from B to A and from A to B. And you can go back in the list of the result to the previous result that you ran previously. You can also try other distance measure as well. So click the text box area, and then in the other dialog, also click the text box area in the nearest neighbor search algorithm. And then from here you can select another distance measure, for example Manhattan distance, Shabu distance, etc. In the next classification example, I will show you how to use neural networks with the Bankruptcy dataset. So from here you click open file and open the Bankruptcy dataset, and look at the list of attribute. Firm is actually the ID of the records, so you don't need this field. So you select and click remove, and if you want you can save the dataset to another file, and then switch to the classify tab. Look for the group functions and select multi-layer perceptron. You can still leave the text option as percentage split with 60% of the dataset for tuning, and also give the output predations checkbox. If you want to specify options for the neural network model, then click the text box. That's the multi-layer perceptron. If you want to see how the neural network looks like, then change the option guide, graphical user interface, change it to true, and later hidden layers. Normally by default it is A. A means that it is equal to attributes, number of attributes plus number of classes divided by 2. But you can also specify how many nodes in the hidden layers you want. You can also specify more than one hidden layer. For example, you specify another hidden layer with 4 nodes, and also specify the learning rate here it is 0.5. So it is running, still building model on training data, and here it shows you how the neural networks look like. The input layer with all the attributes, and you have two hidden layers. The second has 4 nodes, and then the output layer, one node is for class 0 and the other for class 1. You can also training from here, start and accept. And in the result you see the details. For example, this is the sigma node 0 and sigma node 1 that actually connect to node 9, 10, 11 and 12. So this and that are the output node, and node 9, 10, 11 and 12 are the last hidden layer node, hidden layer. And then you see all the nodes in the first hidden layer with all the threshold and width. And class 0 is actually connected to node 0, and class 1 is actually connected to node 1. And down here you see the final result, and this is a conversion matrix, and the accuracy is roughly 75%. Next we go back to the insurance dataset and run the support vector machine algorithm. And here I select the SMO option, and then just click start. And then in the list, in the result you see the list of attributes, the decision boundary. This is a decision boundary using linear kernel, and you see this is the coefficients of the variables. And now it also shows you the list of the predictions on the test split, how the test instances were evaluated. And then the summary. Here the accuracy is roughly 76.5%. Detailed accuracy by class and confusion matrix. And if you have more than 2 classes, and you see more than one decision boundary like this. Next we try the naive Bayes algorithm with the same insurance dataset. And just leave the options the same. Click start. So naive Bayes perform a bit worse, which is around 70% of accuracy. And at the top it also shows you the list of attributes as well as the statistics for each attribute by class. Next we try the backing algorithm with Weka. In order to do so, you select the group meta and then backing. and then click the options, and here you want to select the individual classifier. You can select any individual classifier from here, for example IPK, and then click the options for KNN and change it to 3. So here you basically build multiple k-nearest neighbor multiple models like this, and then the decision of the backing model is basically based on the voting scheme. The decision is based on the majority of the decisions by the individual classifiers, and maybe change the number of iterations to just 5. And this is the result. Under the list of attributes, you see the classifier model with all the base classifiers, and here you have 5 classifiers, 5 base classifiers, as well as the accuracy, some other statistics, the details, as well as the confusion metrics, and also you can use also boosting as well. If you want to use the boosting algorithm, select ala boost, and for individual classifier, for example, I also select IBK with 3 k nearest neighbor, 3 nearest neighbor. And select start, and this is the result. Now I'm going to show you another task in data mining, which is associative rules analysis. So previously we discussed, we showed through a number of classification algorithms, and now we go into associative rule analysis with Weka. And here you select the dataset supermarket.rff in the Weka data folder. So first switch to the tab associate, and then click start. So here I show you the dataset. You select supermarket and click open. If you want to look at the data, then click edit. So here you, for example, in each row you see a number of t or true value. So if it is t, then in that transaction the customer will really buy something from that specific department. And then switch to associate and click start. And then it returns you a number of rules. For example, so if a customer buy a biscuit and frozen food and fruit with the total is high, then it's likely that he also buys bread and cake, and this is the confidence of the rule very high. And next I want to show you how to run Weka in the command line mode. So for running in the command line mode, you can click a simple CLI, and from here you can type in or just copy and paste the commands. In this example, the first line is to train a model using the data in this part. So for training, here the option T is to specify the training dataset, and then the option D is to specify where you want to store the model. And later on, for example, in this example, I just use the same training set for testing. Then for testing, I load the model using L option, and then test using the T option, capital T option, with data from the same set. And if I want to run the example in the window command line, then I can also do that. The only difference is here I use the class path option to specify where I have this file, the Weka.jar file. And next I want to show you how to use the knowledge flow in Weka. So from Weka guide chooser, select knowledge flow, and from here you can build a layout with data sources from here, data scenes from there, filters, classifiers, clusters, association, evaluation, and visualization. So for example, I just click in data source, I click and then click into layout to have an instance of the loader. This is for loading a ARP file. And then I do the same thing. I grab other nodes, and here actually I load a model previously created. So class assigner is to specify which attribute is a class, and then go to you connect. Just right click and connect. And cross validation is to split a data set into a number of folds, and then here you have two models. One is a decision tree and the other is naive Bayes. And then you grab the classifier performance evaluators for each model, and then connect each evaluator to the text viewer and also the performance chart. And I just run it. And when it's done, you can view the result for the decision tree, and also you can view the result for the naive-Bayes model. You can also look at the performance chart. Another model is the clustering model using the Y.C dataset. And here I select the dataset that I previously stored on my computer. And this is a CSV loader, so it can read a CSV file, and then you either remove node, you remove the ID attribute, and the numeric to nominal to convert the class attribute to nominal, and class assigner to assign the class attribute, and change test sublet maker to make it a test and a training dataset. The training dataset is fed to simple k-means node, and then you feed the result to the performance cluster performance evaluator, and connect the evaluator to the text viewer. You feed both test set and training set here, so that you are able to evaluate the performance. So I've just run it and then show the result. So you can see the number of incorrectly clustered instances is 25, is 5, and is 25%. And 1 go to cluster 0, and 0 go to cluster 1. And finally, this is the model for the supermarket dataset using the associative rule analysis. And here I have to load the dataset, the supermarket dataset, connect it to the a priori node, and then the text viewer. So here I run it, and then I can view the result, just what you saw previously if you run it in the Explorer mode. And finally, you can run Weka in the experimental mode. And here I create a new configuration, and then the name of the result file. I save it on my desktop. I can add multiple dataset and multiple algorithms. Dataset first means for each algorithm you go through all the dataset, and if you select algorithm first, then it is the other way around. For each dataset, it is applied to all the algorithms, to each algorithm iteratively. In this example, I select the insurance dataset and 2 algorithms, cleanliness neighbor and decision tree, and then I click run, and it says finished, and there's no error. Then I switch to the analyze tab, and I click file, look for the result file, which is the result.ff, and then from here I can select to configure the test. For example, I select to compare the percentage correct, and click perform test. Then here it shows me the result of the analysis. So basically with Weka experimenter, you can try multiple datasets and multiple algorithms at the same time and compare them and see which one is better than which one.